All right, so here's the second video of 9.3. If you haven't watched the 9.3a, please watch that before this, otherwise it'll make this one a lot more difficult. So this one's primarily talking about the geometric mean. And this is something that I tend to put in words, and then write equations based on that. And you'll see why here in a minute. Okay, so I really hate the way the book presents this to us, so I'm just going to scratch these out. Okay, and if you like it this way, that's fine. I just think it takes away from the conceptual understanding. So as we had said in our vocab in the first lesson, that if I say that x is the geometric mean of number A and number B, then A over X equals X over B. Okay, or another way to write it, and it's the same way as X over A equals B over X, as long as the X's are diagonal from each other and the other two numbers are diagonal from each other, then you're good. Okay, so let's go to some examples and then we'll go back to those other theorems. Okay, so find the geometric mean of the two numbers. So we want to find the geometric mean of 12 and 27. So I'm going to say let x be the geometric mean of 12 and 27. Okay, so I could simply write 12 over x equals, remember x is across from each other, over 27. And then to solve, x squared equals 12 times 27. 12 times 27 is 324. And I believe 324 is a perfect square. It is. The square root of 324, guys, is just 18. So I could say 18 is the geometric mean of 12 and 27. All right. So let's do 6 as well. So let, I don't know, A be the geometric mean of 18 and 54. Okay, so 18 over A equals A over 54. Okay, from here I can cross multiply. So A squared equals 18 times 54. And 18 times 54 is 972. So find the square root of both of those. A equals square root of 972. So let's break 972 down. So 972, 3 goes into that. 324 times. 3 goes into that. 108 times. 3 goes into that. 36 times. 3 goes into that 12 times. 3 goes into 12 4 times. 2 goes into 4 twice. 2 goes into 2 once. We get to 1 word up. So we have a pair of 3s, a pair of 3s, a leftover 3, and a pair of 2s. So 3 times 3 is 6. 6 times 2 is 12, and a leftover 3. So A is 12 square root of 3. So 12 square root of 3 is the geometric mean of 18 and 54. Okay, now go ahead and work through number 7 on your own, and then we'll go over it. All right, so you should have set it up in this way. 16 over x equals x over 18, or you could have done like x over 16 equals 18 over x, same thing, you would have got the same thing, but you should have gotten 12 square root of 2 for your final answer. All right, now let's go back to the two theorems we just skipped. Okay, so we have the geometric mean altitude theorem and the geometric mean leg theorem. So that's the difference between the two. So if we look at this as a big triangle, this would be the altitude, right? And then this would be a leg, and this would be a leg, okay? So there is a difference. So when we want to find the length of the altitude, and once again, I'm going to put this in words. I could say the altitude is the geometric mean of each part, and there's two parts, of the hypotenuse. Okay, so if this is the altitude, one part of the hypotenuse, and I'm looking at this big triangle here, so AB would be the hypotenuse, this would be one part of the hypotenuse, and this would be the other part of the hypotenuse. Okay, I'm going to X this out. So the altitude here is the geometric mean of each part of the hypotenuse. So I'm going to reword that again and kind of plug stuff in. So the altitude would be CD, right? So CD is the geometric mean of the two parts of the hypotenuse of AD and DB. And then if you go one step further, you could write that as a proportion. So AD over CD equals CD over DB. And we will do an example here in a minute. All right. So the geometric mean leg theorem, once again, I'm going to put it in words. I'm going to X these out because I think these are confusing and they don't help with conceptual understanding. So I'm going to say that the leg, and we're talking about the leg of the big triangle, so like CA and CB, is the geometric mean of the entire hypotenuse and the piece of the hypotenuse it touches. Okay, so we have two parts of the hypotenuse. We have this part and we have this part. Okay, so the leg is the geometric mean of the part of hypotenuse it touches and the entire hypotenuse. All right, so let's do CA first. Okay, so I could say that CA is the geometric mean of, okay, so CA is the geometric mean. The leg is the geometric mean of the entire hypotenuse. Well, isn't AB the entire hypotenuse of this big triangle? If this is the right angle, AB would be the hypotenuse. So CA is the geometric mean of AB and the piece of the hypotenuse it touches. So we're talking about CA. It touches this part of the hypotenuse, so AB and AD. And if that's the case, then I could say AB over CA equals CA over AD. Remember, the geometric mean is always opposites of each other. Okay, so that's for one leg. We do it for the other leg. I could say CB is the geometric mean of, and I want you to pick out the two parts that it's the geometric mean of. Okay, so CB, the leg is the geometric mean of the entire hypotenuse, which is AB, and the piece of the hypotenuse it touches. So we're talking about CB, the piece it touches is right here in DB. And because of that, we can write a proportion that AB over CB equals CB over DB. And once again, here's my geometric mean. CB is the geometric mean of my two numbers, AB and DB, AB and DB. All right, so let's look at example 5. Okay, I want to find X, and X is right here. Remember, this is the altitude of the triangle. So I'm going to use the geometric mean altitude theorem. And the geometric mean altitude theorem tells us that the altitude is the geometric mean of the two pieces of the hypotenuse. Okay, and my two pieces are here and here. Okay, maybe I should have done that in another color, here and here. All right, so I could say that the altitude, so x, is the geometric mean of the two parts of the hypotenuse, 4 and 9. Okay, so 4 over x equals x over 9. Geometric means always opposite of each other and listed twice, so I have x squared equals 4 times 9 is 36. Square root both sides, I get x equals 6. They won't always be a pretty number like that. All right, let's look over here. I want to find y. Okay, so y is right here, and y is a leg of this big triangle. So I'm going to use the geometric mean leg theorem, which tells me that the leg is the geometric mean of the entire hypotenuse and the part of the hypotenuse it touches. Okay, so if I start filling stuff in, the leg is the geometric mean. Well, my leg is y, so y is the geometric mean of the entire hypotenuse. Guys, this is the entire hypotenuse. Okay, this is where most people make a mistake. The entire hypotenuse is 2 plus 5 is 7. So y is the geometric mean of 7, and the part of the hypotenuse it touches. So if I'm talking about this blue leg, the part of the hypotenuse it touches is right here. So of 7 and 2. Okay, so now I can set it up. 7 over y equals y over 2. I have my geometric mean opposite of each other, so I can say y squared equals 7 times 2 is 14. Y then has to be the square root of 14, which doesn't simplify. That's my final answer. All right, let's do one last word problem example. It's example 6. So it says to find the cost of installing rock wall into your school gymnasium, you need to find the height of the gym wall. Okay, now the height of the gym wall is from here all the way down. We want to find this height. You use a cardboard square to line up the tip and the bottom of the gym wall. Your friend measures the vertical distance from the ground to the eye and the horizontal distance and approximate the height of the gym wall. All right, so what we have is this triangle. And would you not agree that this here is the altitude of this big, of this scenario? So we would use the geometric mean altitude theorem that says the altitude is the geometric mean of the two parts of the hypotenuse. Okay, well this time it gives us the altitude is 8.5. So 8.5 is the geometric mean of the two parts of the hypotenuse, which is 5 and W. Well, I can set this up. Proportion equals another proportion, and 8 is the geometric, or 8.5 is the geometric mean, which goes here and here. It's geometric mean of 5 and W. Okay, so I get 5W equals 8.5 times 8.5, which is 8.5 squared, which is 7.25. 72.25. There we go. 72.25 equals 5W. Divide both sides by 5. I get, running out of room, so I get W equals 14.45. So if W equals 14.45, the whole wall is from here to here, I would add 14.45 and 5, which the whole wall would be 19.45 feet approximately.